Hi, Professor Bob Young here. In this video, we're going to talk about linear inequalities and three-part inequalities. All right, now remember, we've been doing equations throughout this whole chapter where things are equal, equations equal, but inequalities, on the other hand, ladies and gentlemen, have these in them: less than, greater than. Now, how I always remember is less kind of looks like an L turned sideways. And of course, they could also have the equal sign in them, which means less than or equal or greater than or equal. So here's some properties for inequalities which are similar to properties of equations. If A is less than B for number one, then A plus C is less than B plus C. Guess what property that is? It's the addition property of inequalities. Property 2, if A is less than B and C is greater than 0, that means C is a positive number, then A times C is less than B times C. And step 3, if A is less than B and C is a negative number, if you multiply by a negative or divide by a negative, step 3, you must flip the inequality on properties here, and we'll get to why here in a second. Now notice the bottom down there says replacing the less than or greater with less than or equal or greater than and equal does not affect any of these similar properties. So all of these we could have put, like on step 1, if A is less than or equal to B, then A plus C is less than or equal to B plus C, and so forth. Always remember to flip the direction of the inequality symbol when multiplying or dividing by a negative number. Now, a lot of students don't see why on this one, so let's quickly run through this, and I'll give you an inequality that I hope you all agree with. 10 is greater than 4, and we're going to do a whole bunch of examples with this, so let's just quickly say, all right, if I add 2 to both sides, still true? Yes. Oops, I can't add now. 12 is greater than 6. See, it happens to me, so don't feel bad. All right, so adding doesn't affect the inequality. 10 is greater than 4. Subtract 2 from both sides. 8 is greater than 2. Still true. So adding and subtracting, and again, that's the addition property, because you can always consider that adding a negative, does not affect the inequality. A true statement will still be true when adding or subtracting. 10 is greater than 4. Multiply by 2. The multiplication property, still true. 20 is greater than 8. Young, where are you going with this? You'll see in a second. Hush up. All right. 10 divided by 2 versus 4 divided by 2. If you divide both sides by 2, still true. But notice, ladies and gentlemen, if I take my true statement down here, and I'll do it in red to stay with this rule, if you take and multiply or divide a true inequality by a negative number without flipping, we would get negative, now I can't divide, negative 5 is greater than negative 2. False. See, so with numbers, it makes perfect sense that whenever you deal with these inequalities here, whenever you multiply or divide by a negative number, flip it. Flip it good. You ever heard that old song, whip it? Whip it. Whip it good. Doon, 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 doon. I'm saying on this one, flip it. Flip it good. Now, if you don't flip when you need to flip, your grade gets flipped from A to F. So remember that. All right. Always remember to flip when multiplying or dividing an inequality by a negative number. Now, when I do that to y'all on a test, all right. Now, here's the definition of a linear inequality in one variable, very similar to an equation here. A linear inequality in one variable can be written in this form: ax plus b is greater than 0. A and b are just real numbers. A can't be 0. And all of those other inequality symbols may also be used. Solving a linear inequality. So let's look at this example here. And we will first say, all right, we're solving this linear. Now, why is this linear? Oh, variables to the first power. We've seen this before. Just like this were an equal sign, we're going to treat this greater than sign the same way. We're going to subtract 5 from both sides. That's the addition property of inequalities. Okay, that will lead us down to this step here. Negative 3x is greater than negative 12. we're dividing both sides by -3. Now, this is when sirens have to go off. Woo, woo, red alert, red alert. You have to remember, flip it good. Doom, 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 doom. And then also, when you write the answer, you're going to get what's called interval notation on this inequalities. Now, I do have a whole video designated for interval notation. If you're not sure how to change from inequality notation to interval notation, that's a quick review here. And also here, when you solve for this, you're going to get x is greater than 4. So in interval notation, they will write this answer 4 to infinity with parentheses on the 4. See, so when you go to write this in your software, or if you go to put the answer on the test or whatever, you'll get answers like this, and you must be able to convert to the interval notation. Okay, now this is how your textbook does it, but I think that if you go through the interval notation video, you'll get a lot more out of how to write things in interval notation, although some of you may get this as a quick review here. All right, let's try another example here, solving a linear inequality. So on this one, it looks like they're going to go letters left, numbers right. Now, I always suggest you go letters left on inequalities when you're solving linear inequalities. And on this, I'm going to put A-L-L on this. You know what that means? Always letters left when you're doing inequalities. Because that way, when you solve, you'll know which way you're heading, toward positive infinity or negative infinity. And also, I'm going to go numbers right by subtracting 4 from both sides. So I'm going to just do it straight up and down. And then when I do that, I'm going to end up with -5x is less than or equal to 3. Why didn't I flip? Well, I didn't multiply or divide anything yet by any type number. I think you all see what's coming. Here it comes. Watch out for it. The flipper. So notice x will be greater than or equal to -3/5 again. And since this has the equal to in it, it gets the brackets on the -3/5 and going toward positive infinity. Here is the interval notation answer. So again, when you solve these, you're going to get these type answers, but when you go entering them in your software or on the test, they're going to want those answers. Be careful. Now, this is a 3-part inequality. Some books call them compound inequalities for the last example here. But my roommate, my office mate from Tennessee, we used to share offices at our campus, and his name was Dr. Charlie Joe Allen, and he used to call these type problems tweeners, you know, because I'd go, you know, some of my students are having trouble with these 3-part or compound inequalities, and what's going to end up happening is you're going to get x between 2 numbers on the number line. So when you solve this, he goes, well, this is just telling they're tweeners. That's how Tennessee people say it, tweeners. So x is tween -1 and 5 on the number line. So what you're trying to do on these tweeners is get x by itself in the middle. So to do this, notice we're going to subtract 5 from all parts. Since there's a 3-part one here, we must do that first, which will get us to this step. So I like to put mine straight up and down. I know the graphics do them sideways in the pretty blue, but I'm doing mine in the pretty red. All right, so we'll get down to this statement. Divide everything by 3, as they're doing. So we'll both do, he'll use a pretty blue, I'll use my pretty red. And we will get x is tween -7/3 and 5. And in interval notation, here's how you write it. And remember, when you watch that interval notation, you always write from smallest to largest here, so the negative is always to the left of the positive, just like it is on the number line. And let's do one more example, and we'll call this inequality video done. And this is where you can use inequalities in real life, finding the break-even point. So if the revenue and cost of a certain product, you business majors out there, let's say the revenue is equal to 4x and the cost equals 2x plus 1,000, where x is the number of units produced and sold, at what production level does the revenue at least equal the cost? And that's what they call the break-even point. Until they equal each other, you don't start making money, you business folks. So for the solution, we're always going to set the revenue greater than or equal to the cost so we can figure out that amount. All right, so in this case, we're going to go ahead on R is greater than or equal to C, and we're putting the revenue 4X must be greater than or equal to 2X plus 1,000. And I think that'll make sense to y'all if you're in business. Solving the break-even point is X equals 500, so this product will at least break even only if the number of units produced and sold is in the interval of 500 to infinity. So after you start selling 500 of whatever you're producing there, then that's where you'll break even and start making the money. So you can actually use inequalities in real life, and they are used for you business folks. All right, Bob Young signing off.